Все, да, хорошо, мы готовы. Мы готовы. У нас слышите, все нормально? А, сейчас слышите. Не, ну, в смысле, по телефону. Понял. Да, да, хорошо. Стейкхолдер. Все у нас уже первый слайд. Сейчас я
Так, а сейчас отлично. Все, отлично. Hello, everybody, once again. We are now going to speak about stakeholder management in ER projects. In the first lecture, I've already mentioned that all ER projects have many different stakeholders. And here in the title of the lecture, we can use stakeholder involvement, engagement, but for me, management is preferable because, again, for me, engagement and involvement more the result, and management is more the process. So, the next slide, please. Now about the training objectives. Just a moment. The terminal training objective is to tell about the importance of project stakeholder management in all projects, actually, not only in remediation. Enabling objectives are explain the role and importance of planning the project stakeholder management, present the logic of planning, and explain the features of the use of tools and methods for project stakeholder management. This presentation is based on the special management standard. Maybe some of you heard about it. The standard is PMBOK, Project Management Body of Knowledge. This standard was selected for this presentation also in the framework of the IA project. And when we discussed the selection of certain standard, we decided that PMBOK is the most interesting for us. Okay, the next slide, please. If you want to manage, we need to make some planning process. It is very important. And that's why three next slides are devoted to this subject. Okay. The planning of stakeholder management includes the processes that are necessary for identifying people, groups, and organizations that may affect or may be affected by the ER project. Analyzing the stakeholders' expectation and their impact on the project, possible impact maybe. Developing management strategies for effective stakeholder involvement. The management focuses on continuous communication with stakeholders to understand their needs and expectations. Please pay special attention for the word continuous. Addressing issues as they occur, managing conflicting interests, and fostering the stakeholder engagement in product decisions and activities. And stakeholder satisfaction should be managed as a key project objective. The next slide, please. The general scheme of the stakeholder management includes the following: identify stakeholders, plan their management, manage and control engagement. What does it mean? Identify stakeholders. You must find or determine people, groups, and organizations, analyze and document all significant information about their interest. Very often, their interest may be in conflict. Involvement, interdependencies, influence, and possible impact on the success of the project. So first of all, you should identify. Then you should plan the management. Develop management strategies for effective engagement throughout the project life cycle, through all the project. Manage the engagement. That means communication and work with stakeholders to meet their needs and expectations, responding to their problems as they arise, and promoting their engagement. And you should also control the engagement. Monitor all the relationships of the project stakeholders, adjusting the strategies and plan for the stakeholder engagement. On different stages of ER project, these strategies, management strategies, can be different. The next slide, please. What is very, very important? We should remember that all projects have stakeholders. Absolutely. Stakeholders can affect the project and its result to different degree and in different ways. The ability of project manager to identify and manage their stakeholders in a proper way can determine the success or failure of the project. And here the main stakeholders of the ER project. You can see government, employees, suppliers, lenders, local community, society in general, owners, say owners of land, or owners of technologies or technique, and customers. Actually, there are much more stakeholders. The next slide, please. This is the logic of the standard PMBOK. And this document, it's rather big, the 5th edition, about 700 pages. And I would say this document is rather difficult to understand and sometimes rather boring. But the logical scheme is very good. You see, again, the 4 stages: identify, plan, manage, control. And they are all described according to the same plan: inputs, tools and techniques, and outputs. What we have at the end of the process, how we reform inputs into outputs with the help of tools and techniques. Okay, next slide, please. This is the picture from the PMBOK standard. The same thing. Okay, what we see here. Just a moment. Okay. Identify, again, identification of people, groups, or organizations. Analyze and document relevant information from these subject. By the way, sometimes if the contaminated territory are close to a border or the state border, maybe stakeholders be the countries, states. The key benefit of this process: it allows the project manager to identify the appropriate focus for each stakeholder group or each stakeholder. Who are project stakeholders? How actively they are involved or will be involved in the project? Stakeholders may be at different levels within the organization, even within organization. It is critical to identify stakeholders early in the project or phase of the project. Most projects will have a diverse number of stakeholders. Let's look at the picture. Inputs: project charter, procurement documentation, enterprise environmental factors, organizational process assets. Output: stakeholder register. And we turn inputs into outputs with the help of stakeholder analysis, expert judgment, and meetings. Let's see how we do it. Again, don't forget that stakeholders may affect or be affected by or perceive themselves to be affected. Maybe they are not affected, but they think that they are by a decision, activity, or outcome of a project. This idea, let's try to understand you more in more details. The project charter can provide information about internal or external parties related with the project and affected by the result of the execution of the project, such as project sponsors, customers, team members, groups and departments participating in the project, and other people or organizations affected by the project. So this is all described in project charter. Procurement documentation. If a project is the result of procurement activity, as a rule, it's true, or is based on an established contract, The parties in that contract are key project stakeholders. Other relevant parties, such as suppliers, should also be considered as part of the project stakeholder list. So this should be taken into the project, included. Enterprise environmental factors. What's this? The enterprise environmental factors that can influence the identify stakeholders process include, but are not limited to, organizational culture and structure, government or industry standards, that is regulations, product standards, and global, regional, or local trends and practices or habits. So the word environmental means environment of the organization. And organization process assets include, but not are limited to, stakeholder register templates, lessons learned from previous projects or phases, and stakeholder registers from previous projects. Okay, I think it's understandable. How we work with all this? First of all, we should analyze our stakeholders. And the result of such analysis is very important for future. Analysis generally follows the steps as follows. Identify all potential project stakeholders and relevant information. Excuse me for a moment. Так, слушаю вас. Да. Ну, ждем, конечно. Понял, спасибо. Спасибо, до свидания. I'm very sorry, it was very important call. So we should also take into consideration all interests, knowledge, expectations, and influence levels of these stakeholders. Key stakeholders are usually easy to identify. They include anyone in a decision-making or management role who is impacted by the project outcome, such as the sponsor, project manager, primary customer. Identifying other stakeholders is usually done by interviewing the key stakeholders. Then we should analyze the potential impact or support each stakeholder could generate and classify them so as to define an approach strategy. In large stakeholder communities, it's important to prioritize, to find the most important stakeholders to ensure the efficient use or effort to communicate and match their expectation. Okay, how we can do this analysis? I won't speak about expert judgment. I think it's very easy. And the meetings, just meetings. Very interesting are the instruments of analysis. The next slide, please. Okay. And the next. Identify stakeholders, tools, and techniques. Stakeholder analysis 2 from 3. Yes? Okay, what are instruments? There are different classification models used for stakeholders analysis. Power or interest grid, power influence grid, influence impact grid. All these instruments should group the stakeholders based on their level of authority and level of concern, or level of authority and involvement, or ability to effect changes to the project planning or execution. The next slide, please. Here, you can see example of a power interest grid with H representing the placement of generic stakeholders. You see that this square is divided into 4 parts. On the axis, left axis, we see power from low to high, and horizontal axis, interest from low to high. It is quite understandable that you should concentrate on the stakeholders B, F, and H, because they have high interest and rather high power. Stakeholders C and E should be kept informed because they haven't got much power but high interest. Stakeholder E should be kept satisfied, and D and G just be monitored. Rather interesting instrument. You can use it sometime. I tried to do it. The next slide. Tools and techniques, expert judgment and meetings. To ensure comprehensive identification and listing of stakeholders, judgment and expertise should be sought from groups or individuals with specialized training or subject matter expertise. Who are these people? First of all, of course, senior management. Then it can be other units within the organization, departments maybe. Key stakeholders, whom you already identified. Project managers who have worked on projects in the same area. Subject matter experts in the business or project area. Industrial groups and consultants. And professional technical associations, regulatory bodies, and non-governmental organizations. How to do it? The judgment can be obtained through individual consultations, one-on-one meeting, interviews, etc., and maybe in panel format, focus groups, surveys, etc. Meetings are very simple but very useful instrument, and these meetings should be regular to keep informed the stakeholders and experts and to understand their opinions. Next slide, please. What we have for outputs. Stakeholder register. It's a very important document, and this can be used. It can be used not only for this particular project, but also in future. The main output stakeholder register. This contains all details related to the identified stakeholders, including but not limited to identification information, name, organizational position, location, role in the project, contact information. It's understandable that this information may change during the project. Assessment information, major requirements, main expectations, potential influence in the project or stage of the project. And stakeholder classification, internal, external, supporter, neutral, resistor, etc. The stakeholder register should be consulted and updated on a regular basis, as stakeholders may change or new ones identified throughout the life cycle of the project. What's the register? How the register looks like? The next slide, please. You can see that you have a table, role of stakeholder, contact information, category, interest, influence, expectations, and necessary comments. Rather simple. Okay. The next slide, please. Again, we look here and we see inputs, tools and techniques, and outputs. Inputs. Project management plan. Stakeholder register from the previous stage. Enterprise environmental factors. We already know what does it mean. And organizational process tests. Outputs are stakeholder management plan and project documents updates. The tools and techniques almost the same. Expert judgment, meetings, and analytical techniques. The process of developing appropriate management strategies to effectively engage stakeholders throughout the project cycle. The process identities how the project will affect stakeholders, which allows the project manager to develop various ways to effectively engage stakeholders in the project and to manage their expectations and ultimately achieving the project objectives. Stakeholder management is more than improving communications and requires more than managing a team. The process generates the stakeholder management plan, which contains detailed plans on how effectively manage the stakeholder. As the project progresses, the membership of the stakeholder community and level of engagement may change. And therefore, stakeholder management planning is an iterative process that is reviewed on a regular basis by the project manager. So you can understand that, say, production technologies or remediation technologies, very important things. But here, this process with stakeholder may be much more difficult. The next slide, please. Oh. Again, come back to inputs. Project management plan. The information used for the development of the stakeholder management plan includes life cycle selected for the period and the processes that will be applied to each stage. Description of how work will be executed to accomplish the project objectives. Description on how human resources requirements will be met and how roles and responsibilities, uh, reporting relationships, and staffing management will be addressed. Change management plan that document how changes will be monitored and controlled, and need and techniques for communication among stakeholders. Uh, we already know what stakeholder register is, and we already understand what are enterprise environmental factors and organizational process assets. The next slide, please. Tools and techniques. Again, expert judgment. The first instrument. We see the same list of potential experts. And the same instrument. You can provide individual consultations, meetings, interviews, or panel formats. And again, meetings should be held with experts and the project team to define the required engagement levels of all stakeholders. This information can be used to prepare the stakeholder management plan. The next slide, please. Here, we can see one more interesting analytical instrument, analytical techniques. The current engagement level of all stakeholders need to be compared to the planned engagement levels. That is you assess their current engagement and you should understand what do you need from them, from stakeholders. during the project lifecycle. I think engagement level can be classified as follows. Понятно. Так, понятно. Прямая трансляция. Ага, отлично, отлично. Так, на каком месте там оборвалось? 18-й слайд. Угу, понял. Okay. So on this slide, the tools and techniques for planning stakeholder management are presented. And we speak about analytical techniques. Here we see one more interesting instrument. This is a kind of comparison of stakeholders. I mean their present engagement in the project and their desired engagement during the life cycle. The engagement level can be classified as follows: unaware, resistant, neutral, supportive, and leading. Unaware, stakeholders that know about project and potential, don't know about project and potential impacts. Resistant, aware of project and potential impacts, and they don't want all these changes. Neutral, aware of project, yet neither supportive nor resistant. Supportive, aware of project and potential impacts and supportive to change. And leading, aware of project and potential impacts and actively engaged in ensuring the project success. The current engagement can be documented using stakeholder engagement assessment metrics. You see it on the table. As shown in the figure, where C indicates the current engagement and D indicates the desired engagement. So you see, stakeholder 1, stakeholder 2, stakeholder 3. Stakeholder 1 currently is unaware, but we, as a project managers, we need it to be supportive. Stakeholder 2, neutral, and we also need it to be supportive. And stakeholder 3, the current engagement and desired engagement are the same for us. Now you can see that the most difficult work will be with stakeholder 1. Stakeholder 2 is okay, and stakeholder 3, we just need to keep it informed. So also rather interesting instrument for comparison of current state of things and desired state of things. Okay, the next slide, please. Next slide. Okay. Outputs of planning stakeholder management. We started with a project management plan, and as outputs, we should have a stakeholder management plan, a component of the project management plan, practically. This component identifies the management strategies required to effectively engage stakeholders. In addition to the data gathered in the stakeholder register, the stakeholder management plan often provides desired and current engagement level of key stakeholders. We just spoke about it now. Scope and impact of change to stakeholders, identified interrelationships and potential overlap between stakeholders, stakeholder communication requirements for the current project phase, information to be distributed to stakeholders, including language, format, content, and level of details in this information. Reason for the distribution of that information and the expected impact to stakeholder engagement. You need to forecast this thing. Time frame and frequency for the distribution of required information to stakeholders. And, which is important, method for updating the stakeholder management plan as the project progresses and develops. Project managers should be aware of the sensitive nature of the stakeholder management plan and take appropriate precautions. For example, information on stakeholders who are resistant to the project can be potentially damaging, and due consideration should be given regarding the distribution of such information. When updating the stakeholder management plan, the validity of underlying assumption should be reviewed to ensure continued accuracy and relevance. So, taking into consideration all this information, additional information, we need to update the project documentation, project schedule, and stakeholder register, mostly. The next slide, please. So we identify our stakeholders, we plan the management. Now we need to manage this engagement. Again, inputs, tools and techniques, and outputs. What we have as inputs: stakeholder management plan. Then a new thing for us, communications management plan, change log, and again, organizational process assets. For outputs, we have issue log, change register requests, project management plan updates, project documents updates, and organizational process assets updates. Something new for us. A process of communicating and working with stakeholders to meet their needs and expectations, address issues as they occur, and foster appropriate stakeholder engagement. The key benefit of this process is that it allows the project manager to increase support and minimize resistance from stakeholders, significantly increasing the chance to achieve project success. Managed stakeholder engagement involves activities such as engaging stakeholders at appropriate project stages, managing stakeholders' expectations through negotiations and communication, addressing potential concerns that not yet become issues, and anticipating future problems, and clarifying and resolving issues that have been identified. Again, a rather complicated process. Let us consider inputs. Stakeholder management plan we developed on the stage of planning management. And this plan provides guidance on how the various stakeholders can be best involved in the project. Actually, guidance. The plan describes the methods and technologies used for stakeholder communication. Now, communication management plan provides guidance and information on managing stakeholders' expectations. The information used include stakeholder communications requirement, information to be communicated, including language, format, content, and level of detail, reason for distribution of information, person or groups who will receive information, and escalation process. Change log, used to document changes that occur during the project. These changes and the impact on the project in terms of time, cost, and risk are communicated to the appropriate stakeholders. And organizational process assets, a little different than we saw before. The organizational process assets that can influence the managed stakeholder engagement include organizational communication requirement, issue management procedures, change control procedures, and historical information about previous projects. The next slide, please. Tools and techniques we may use to manage stakeholder engagement. Communication methods, interpersonal skills, and management skills. What's this? Communication methods. The methods of communication identified for each stakeholder in the communication management plan are utilized during stakeholder engagement management. Based on the stakeholder communication requirements, the project manager decides how, when, and which of these communication methods are to be used in the project. For example, when we work with our trainees from Central Asia, we ask them how people in their country get access to information. And it occurred that in one country, the main method, newspapers, in another country is radio. That is, it's important how to give information to different stakeholders. Interpersonal skills. The project manager applies interpersonal skills to manage stakeholders' expectations. For example, building trust, resolving conflict, active listening, and overcoming resistance to change. Management skills. The project manager applies management skills to coordinate and harmonize the group toward accomplishing the project objectives. For example, facilitate consensus toward project objective, influence people to support the project, negotiate agreements to satisfy the project needs, and modify organizational behavior to accept the project outcome. The next slide, please. A lot of outputs. Issue log. Management stakeholder engagement may result in the development of an issue log. This log is updated as new issues are identified and current issues are resolved. Change request. Managing stakeholder engagement may result in a change request to the product or the project. It may also include corrective or preventive actions. Project management plan updates, project document updates, and organizational process assets updates. Stakeholder notification, project reports, project presentations, project records, feedback from stakeholders. The next slide, please. Okay, when we manage our stakeholders' engagement, we need to control. Again, inputs, tools, and techniques and outputs. What we have as impacts is inputs, sorry. We have project management plan, issue log, work performance data, and project documents. Point 3 is new for us here. Outputs are work performance information, change request, project management plan updates, project documents updates, and organizational process assets updates. Tools and techniques, information management system, new, expert judgment, and meetings. We know about them. Okay, control stakeholder engagement is the process of monitoring overall project stakeholder relationships and adjusting strategies and plans for engaging stakeholders. The key benefit of this process is that it will maintain or increase the efficiency and effectiveness of stakeholder engagement activities as the project evolves. And the stakeholder engagement activities are included in the stakeholder management plan and are executed during the life cycle of the project. Stakeholder engagement should be continuously controlled. Continuously. From the very beginning. Next slide, please. Okay. What is project management plan? Used to develop the stakeholder management plan. The information used to control stakeholder engagement includes the life cycle selected for the project and the processes that will be applied to each stage. How work will be executed to accomplish the project objectives. How human resources requirements will be met. How roles and responsibilities, reporting relationships, and staffing management will be addressed. A change management plan that documents how changes will be monitored and controlled. Needs and techniques for communication among stakeholders. Very important that you, as a manager, you not only communicate with each stakeholder, you should organize the communication among them. Issue log. The issue log is updated as new issues are identified and current issues are resolved. Work performance data. That's a new point for us. The primary observations and measurements identified during activities being performed to carry out the project work. Various measurements on project activities and deliverables are collected during various controlling processes. And project documents. Many of them, but the most important are, for this stage, project schedule, stakeholder register, issue log, change log, and project communications. Next slide, please. Tools and techniques of controlling process. Information management systems provides a standard tool for the project manager to capture, store, and distribute information to stakeholders about the project cost, schedule, progress, and performance. It will also allow the project manager to consolidate reports from several systems and facilitate report distribution to the project stakeholders. As for expert judgment and meetings, it's just the same instrument as in the previous slides. The next slide, please. A lot of outputs in this process. Work performance information. Performance data collected from various controlling processes. Excuse me. Should be analyzed in context and integrated based on relationships across area. Thus, work performance data have been transformed into work performance information. Please pay attention that performance data are transformed into performance information. Change requests, analysis of project performance, and interaction with stakeholders often generates change requests. These change requests are processed according to the established procedure. That is, all changes should be formalized in some papers. Project management plan updates. As stakeholders engage with the project, the overall effectiveness of the stakeholder management strategy can be evaluated, and changes in approach or strategy are identified. Elements of the project management plan that may be updated include, but not are limited to, change management plan, communications management plan, cost management plan, human resource management plan, procurement management plan, quality management plan, requirements management plan, risk management plan, schedule management plan, scope management plan, and stakeholder management plan. Very complicated. You understand that working with a project, You may or may not work with all these kinds of plans, depending on the character of a particular project. Next slide, please. Outputs of the controlling process. Project documents updates. Understandably, when you control, you need to update all this. Stakeholder register. This is updated as information on stakeholders change. And issue log. This is updated as new issues are identified and current issues are resolved. Organizational process assets updates. They include, and again, maybe not limited to, stakeholder notifications. Information may be provided to stakeholders about resolved issues, approved changes, and general project status. Project reports. Formal and informal project reports describe project status and include lessons learned, issue logs, project closure report, etc. Project presentations. Information formally or informally provided by the project team to any or all project stakeholders. Project records include correspondence, memos, meeting minutes, and other documents describing the project. Feedback from stakeholders. This is information received from stakeholders concerning project operations. And lessons learned documentation includes the root cause analysis of issues, faced reasoning behind the corrective action clause, and other types of lessons learned about stakeholder management. Lessons learned are documented and distributed so that they became part of the historical database for both the project and performing organization. The next slide, please. Okay, this is maybe a more informal thing, but very important. So, practical tips for communication. Providing stakeholders with information about the various stages of the project and the time of possible execution of individual operations should be absolutely minimal. The information for everyone should be the same and come at the same time for all stakeholders. Stakeholders should be invited to dialogue, which should be considered not as a hindrance or delay of the project, but as a way to promote and improve the project. It is necessary to show that the opinions of stakeholders are taken into account. If they are not accepted, it is necessary to argue why. All requests for information should be considered in a timely manner. The next slide, please. And a little more about practical tips. It is better to place information related to risks in a broader context. For example, the real situation before remediation and desired situation after. Actually, depending on stakeholders, sometimes it's better not to use the word risk at all, because the experts, the perception of this word by experts and by general public can be very, very different. For experts, risk means uncertainty, and for general public, often this word means danger. We shouldn't discuss the situation at all. It's important to talk about specific cases and projects. Communicators should be able to clearly state the assumptions and suppositions that are made in the process of researchers' considerations and discussions. To overcome the difficulties associated with uncertainties or with risks, you can use the presentation of scenarios in the best case, as a rule, in the worst case. If the information is provided by several independent entities, it is necessary to coordinate the activities. But at the same time, it's not necessary to seek coordination of positions. So coordinate activities, but not positions. Okay, we are coming to the end. We spoke about the importance of project stakeholder management, and we saw that this process is very complicated, and it needs very different skills. We spoke about the role and importance of planning, stakeholder management, logic, stakeholder management, and we saw the features of the use of tools and methods for project stakeholders management. Well, that's all for the moment. Thank you very much for your attention. Bye-bye.
Спасибо большое. Вы нас слышите?
Слышу.
О, отлично.
Вот теперь слышу.
Наконец-то. Спасибо большое. Does somebody have any questions?
Who manages the conflicts between
Sorry, maybe. There's one question. What was the question?
Can I?
Yeah.
So who deal with the conflicts if arises, and who appoints the stakeholders, and who manages the conflicts among the stakeholders?
So the question is, who is actually managing these stakeholders communications and
Conflict and the negotiation.
And conflicts and negotiations? Who should do it?
So
actually, there can be very different specialists, and they, for me, they may have some special skills for communication, for negotiating, but the role of manager is to find the appropriate people for this.
But what is the organization? It is owner of the facility,
yes,
or
that's the mind. That was my question.
so is it some regulatory body, or who by the organization? When we're talking about organization,
You know, as far as I know, there are not a special organization for all projects. You see, in the framework of any project, there should be a kind of department or something, because projects, all projects are, okay, they have individual character, and they deal with different activities and different stakeholders. So maybe, but I'm not sure. Maybe there are some recommendations, say in IA documents for special activities. For I know that there is a book in Russian and in English speaking about the communication with the population of a Chernobyl area. And my friends worked with this book.
Okay. So in general, it is the company who is working on decommissioning.
Responsible, yeah.
Yeah. Okay.
My question is, which decision concerning the commissioning require stakeholder involvement?
Sorry?
Yeah, which decision concerning the commissioning require stakeholder involvement?
Which? Yeah, you can just ask. Okay, I cannot say. But which decisions concerning decommissioning require the stakeholder involvement?
You know, in my personal experience, we just started to deal with decommissioning because since say 2015, we mostly work with Central Asia, and they dealt with remediation, not with decommissioning. So it's quite a new thing for us. So
but
far.
for remediation, for example, which decisions should be negotiated or discussed with stakeholders?
One practical example. In Kyrgyzstan, there was a rather strong resistance to remediation from the very beginning, because people feared that the removal of contaminated materials will endanger them. So they even make a protest demonstration. Women and children close the roads and didn't let the transport to go by this. So they have to work individually with the communities. They gathered people. They interviewed the most influential people, including religious leaders. So again, it's this, for my perception, this communicative thing and stakeholder issues much more complicated than technology.
Okay, thank you.
Thank you very much.
You're welcome.
Thanks again for your presentations, and we're finishing this part of our day. And thank you again.
Thank you. Bye bye.
Victor, прощение. Excuse me. Victor, excuse me. Do you hear me?
We can write a message if not, or he's not reachable.
Victor, are you hear me?
Or we can directly write the question. Who is responsible for the safety? Who is liable and responsible for the safety? Who is liable? For the accidental you will get it then you can
You can exclude a lot of possibilities just because we narrow down Алексей, добрый день.
Алло, вы меня слышите, видите?
Да, слышу, видим.
Хорошо. Давайте я попробую пошерить слайды.
Да.
Так, сейчас, одну минутку.
Да, красота, все видно.
Все нормально?
Да, супер. Супер.
Ну хорошо, ладно.
Будем
Свяжемся.
Да, я думаю.
Да. Дайте-ка.
Расслабление, спокойная и приятная музыка круглосуточно. И следующая песня будет о красивых и пышных облаках. Привет, Мэдди. Извини, милая. Мамочка временно сошла с ума и уехала далеко-далеко. Так что какое-то время мы с тобой будем вдвоем. Вдвоем.
Дети, вы не тронули сэндвичи. А если вы хотите пить, у нас есть ломат. Мистер Кит и соевое молоко. Мы не хотим пить. Пожалуй, я пойду спать. Но сейчас 12:30 дня. Я прекрасно знаю, сколько времени. Лиза, ты будешь спать со мной, Бак, а ты с этих пойти. Я должна тебя предупредить, что ужасно храплю. Наша любимая
Алексей,
Да.
Мы готовы.
Ну что, начинаем?
Буквально минута. Сейчас я займусь.
Хорошо, просигнальте.
Алексей, let's start.
Начинаем, да?
Да.
Okay. Hello, everyone. Can you see and can you hear me? Yes, good, good. So, greetings from Fukushima, Japan. My name is Alexei Konoplev. Originally, I am Russian environmental chemist, let's say, and I graduated back in 1977, chemistry department of Moscow State University, where you are now. And I'm very proud of that.
I love that.
Okay, I will start now to try to share slides. Can you see the slide?
Yes. Yes.
Great. Okay. Today, I represent Institute of Environmental Radioactivity at Fukushima University, where I work for last 8 years. The title of my lecture today is Radionuclide Behavior in Contaminated Areas, Mayak, Chernobyl, Fukushima. So, let me first briefly introduce you our institute, which was established in 2013 with clear objective to organize and carry out fundamental studies of the national and international level on behavior of Fukushima-derived radionuclides in the environment and their biological effects. The institute is located in the Fukushima University campus, 60 kilometers away from Fukushima Daiichi nuclear power plant. And this is very convenient location to carry out the field work in contaminated areas. Here you can see, here is Fukushima Daiichi nuclear power plant. This is the 60 kilometers circle. And here is the campus of Fukushima University, which is 10 kilometers away from Fukushima City, which is the capital of Fukushima Prefecture. So Fukushima Daiichi means Fukushima #1, because there were 2 nuclear power plants in Fukushima Prefecture. And this one is #1. Here you can see the campus of our Fukushima University. And here 2 buildings belonging to our institute. The main building contains of offices of professors, meeting rooms, classrooms, because we are teaching master and PhD students. And this is the laboratory building, which is for instruments, analytical instruments for our field and laboratory work. And this is our team of our institute. So it's not very large institute, but quite efficient. And it is international. Majority of people, of course, are Japanese, but also other nationals. This is the outline of my lecture today. So I will talk about speciation of radionuclide in atmospheric fallout, about solid liquid distribution and bioavailability of accidentally released radionuclides, about wash off from contaminated watersheds, then river transport and trapping of radionuclides by dam reservoirs. I will also tell about the self-purification and natural attenuation after the radioactive contamination. And finally, we will discuss the long-term dynamics and its modeling. So, we will consider 3 contaminated areas today. Mayak area in modern Russia, Chernobyl nuclear power plant, contaminated areas in modern Ukraine, but contaminated areas are also in Belarus and Russia, and many others European countries, but mostly were contaminated Ukraine, Belarus, and Russia. And area contaminated as a result of Fukushima Daiichi nuclear power plant in Japan. So chronologically, we have first contaminated area at Mayak. And here you can see the radioactive trace, East Ural radioactive trace, which appeared after the accident in 1957. But that was not nuclear power plant or even reactor accident. That was accident at the storage of high level liquid radioactive waste, special tank which exploded. Then we will consider the contaminated areas after the Chernobyl nuclear power plant, which happened in 1986. And this is still the most severe nuclear accident ever happened. And finally, in 2011, Fukushima Daiichi nuclear power plant accident happened. And here you can see the trace of Fukushima Daiichi nuclear power plant accident. So, unfortunately, during the development of Mayak, which is the special nuclear facility, which was established in 1948 for the production of nuclear weapon grade plutonium. So a combination of major errors in judgment and technical features caused severe environmental contamination in the vicinity of Mayak. Major incidents are presented over here. First source of radioactive contamination in the area was direct discharge of intermediate liquid radioactive waste to the Techa River. Techa River is going over here. And here is the Mayak site. And intermediate and low-level liquid radioactive waste was dumped directly to Techa River during 1949-1956. Then the second source of radioactive contamination in this area, Mayak area, is discharge of liquid radioactive waste, intermediate and low level, to the Lake Karachay from 1951. This lake doesn't exist anymore because of intensive and extensive remediation program. This lake was completely fulfilled and covered. So because this was the most contaminated lake on the earth. Then in 1957, so-called Kyshtym accident happened. However, the town Kyshtym has nothing to do with this accident. Kyshtym is located over here, and this is a regular city, and population of this city even didn't know that they have so dangerous nuclear neighbor as Mayak. However, this accident historically is called Kyshtym accident because this is the closest city with the site. And fourth source of radioactive contamination was wind transport of contaminated sediments from Lake Karachay in 1967. This was very dry spring and summer in this year, and Lake Karachay, which was extremely highly, severely contaminated by radioactive substances, this Lake Karachay was drying down, and bottom sediments became exposed to the air. At the same time, during the summer of 1967, there was blow wind, which resuspended radioactively contaminated particles and transported over the quite remote areas away from Mayak. So there are four important sources of radioactive contamination in Mayak. This is few pictures about the Chernobyl accident, which is the most severe nuclear accident. As a result of Chernobyl accident, about 85 petabecquerel of cesium-137 and 54 petabecquerel of cesium-134 were released into the atmosphere. Also, 1,760 petabecquerel of iodine-131, 10 petabecquerel of strontium-90, and 0.07 petabecquerel of plutonium-239 and 240. So this is the brief information about the accident in on Fukushima Daiichi nuclear power plant. So you probably know that 11 March of 2011, the strongest earthquake happened for the whole history of observation in Japan. And here you can see the Fukushima Daiichi nuclear power plant, how it looked like before the accident. So here you can see as a result of the most severe earthquake was of magnitude more than 9, like 9.1. As a result of this earthquake, the epicenter of the earthquake was about 80 kilometers from the coast of Japan. And there was a very big tsunami after this earthquake. And here you can see what happened in Fukushima Daiichi nuclear power plant. So the height of the wave of the tsunami was about 15 meters. Of course, the designers of Fukushima Daiichi nuclear power plant tried to prevent damage from tsunami. They constructed the wall, protection wall, but the height of protection wall was only 5.7 meters. And the wave of tsunami overcame this wall very easily and attacked actually the buildings of Fukushima Daiichi nuclear power plant. Of course, due to earthquake, the electric power was destroyed during this earthquake. But of course, there is a spare source of electricity on the power plant, but they were located underneath of the building, on the ground, and were flooded. Moreover, unfortunately, the building was not hermetically isolated, and the water penetrated to the building and damaged these sources. As a result of these events, the meltdown of the reactor happened, and so the explosion took place. And here you can see, this is the explosion, and here you can see the results of this accident. Destroyed buildings of 4 units of the nuclear power plant. As a result of this accident, a lot of volatile radionuclides were evaporated and released to the atmosphere, mostly iodine-131 and cesium isotopes, cesium-134 and cesium-137. So, however, iodine-131 has a half-life of 8 days. And therefore, after several months, this danger disappeared. Cesium-134 has a half-life 2 years, and cesium-137 has a half-life 30 years. So, at the moment of the release, the ratio of cesium-134 and cesium-137 was 1 to 1. Nowadays, 10 years after the accident, the ratio is less than 10%. So you can easily calculate, this is your homework. What is the ratio of cesium-134 to cesium-137 right now, after 10 years after the accident? Taking into account that at the moment of accident, it was 1. So here you can see two maps of cesium-137 contaminated areas after Chernobyl nuclear power plant and after Fukushima Daiichi nuclear power plant. These maps are made in the same scale. So you can compare the, let's say, consequences of these two accidents. The conclusion from this comparison is very clear. We have comparable levels of contamination of soil and deposition, but in Fukushima, it's over much smaller area. As I told you already, as a result of Chernobyl nuclear power plant accident, 85 peta-becquerel of cesium-137 was released. In case of Fukushima Daiichi nuclear power plant accident, 15 peta-becquerel of cesium-137 was released, 5.5 times less. But moreover, Fukushima Daiichi nuclear power plant is located on the coast of Pacific Ocean. And 80% of the cesium-137 released by the accident at Fukushima Daiichi nuclear power plant was transported over the Pacific Ocean and deposited on Pacific Ocean. Of course, the volume of Pacific Ocean is very huge, and this deposited cesium-137 was diluted in the water of Pacific Ocean up to the negligible levels. Okay, and only 20% of released cesium-137 were deposited on the land, on the terrestrial and aquatic, freshwater aquatic system. Overall, we have difference in releases, 5.5, and also only 1/5 part in Fukushima was deposited on the land. Therefore, the area seriously contaminated should be less, about 25 to 30 times. So this comparison gives you corresponding picture. Okay. So behavior of radionuclide in the environment is governed by two major factors. First, radionuclide physical chemical properties and their speciation in the fallout and transformation of the speciation. And the second, climate and environmental characteristics determining radionuclide fate and transfer. In terms of speciation, in case of Kishtim accident or accident at Mayak, radionuclide were released mostly in soluble forms because this was actually liquid radioactive waste. So mostly solutions. In the case of the Chernobyl accident, radiocesium was incorporated to a great extent in fuel particles, which were insoluble in water. Chemical forms of radiocesium resulting from the Chernobyl accident were depending on the distance to the Chernobyl nuclear power plant, since fuel particles primarily deposited in the vicinity of the damaged reactor and radiocesium transported over large distance was that incorporated in so-called condensation particles that are easier soluble in water. In Fukushima case, the studies have revealed spherical glassy hot particles containing, besides radiocesium, uranium, and other elements specific to nuclear fuel and reactor materials. These particles are also insoluble in water, and radiocesium leaching from them is even slower than from Chernobyl fuel particles. On the slides, you have electron microscope images of fuel particles. Here are the fuel particles. And here you can see the cesium balls or glassy hot particles from Fukushima Daiichi nuclear power plant release. You see they are very spherical and they are glassy. They contain mostly silicon, dioxide of silicon. So here you can see the time dependence from 26 April of 1986 to the start of May of speciation of cesium, red, and strontium in the deposition, in the fallout. This was studied using the sheets which were exposed to atmospheric fallout on the meteorological station in Chernobyl town, about 15 kilometers away from Chernobyl nuclear power plant. You can see that the mobility of cesium and especially strontium was very low. Mobility means solubility and exchangeability with water. This table demonstrates you comparison of the speciation of radionuclides, cesium-137 and strontium-90 after Chernobyl accident, nuclear weapon test, and Fukushima. Importantly, that the deposition of radiocesium on different distances from Chernobyl nuclear power plant were different. You see that mobility of radiocesium in Western Europe was much higher than in Russian contaminated areas, and especially in close-in 30 kilometers zone of the Chernobyl nuclear power plant. Therefore, the mobility and bioavailability of radiocesium on different traces, different spots of the contaminated area was different. In case of nuclear weapon tests, more than 80% of radiocesium was in mobile forms. This is quite similar with the mobility of Chernobyl radiocesium in UK and Western Europe. Therefore, the results and parameters of radiocesium migration, which were obtained with nuclear weapon tests, could be easily applied for the areas contaminated after Chernobyl in Western Europe, but could not be directly used for close-in zone and mid-range distances from Chernobyl nuclear power plant. In case of Fukushima, because of release of these glassy hot particles, the mobility is also very variable depending on how many particles, such particles were deposited. And it varies from 20 to about 70% of mobile forms. And here you can see the similar table for strontium. However, strontium was not released in case of Fukushima, or only very negligible amounts of strontium-90 were released in Fukushima. In case of nuclear tests, more than 90% of strontium-90 is mobile. The similar fraction is for Kyshtym or Mayak accident, 80 to 90%, because in Mayak accident, so liquid radioactive waste was released, which is actually the solution. But in Chernobyl, in case of Chernobyl, majority of strontium-90 was deposited in 30-kilometer zone. And here we had mobility only 10 to 50% of strontium-90. This is because other 85, 90% of strontium-90 were incorporated in fuel particles, or particles of nuclear fuel, of uranium dioxide, or products of its oxidation, uranium-3 oxide and intermediate oxides. And they were initially were characterized by low mobility and bioavailability. So we have found that radiocesium in Fukushima is stronger bound to soil particles than Chernobyl-derived radiocesium. This means that its bioavailability for plants and aquatic biota is lower than in Chernobyl. We believe there are two major reasons for that. First, high ability of Fukushima soils to selectively sorb and fix radiocesium. And second, occurrence of insoluble glassy hot particles in fallout. Here you can see the illustration of the mechanism of radiocesium selective sorption on so-called fried edge sites of micaceous clay minerals. And images of spherical glassy hot particles released as a result of Fukushima accident. Two major reasons of strong binding of radiocesium by soils and sediment particles. This table demonstrates comparison of distribution coefficients in Fukushima rivers with rivers in Chernobyl area. Distribution coefficient is the ratio of concentration of radiocesium on soil or sediment particles to the concentration in water. Interesting is that KD for pre-Fukushima deposition, global and Chernobyl fallout in Japan were similar to Chernobyl rivers and much lower as compared with post-Fukushima KD values. This is the previous Japanese data. They are quite similar with Chernobyl data, but at least order of magnitude lower than Fukushima-derived radiocesium KD. KD characterizes the distribution of radiocesium between solid and liquid phase in the environment. So this similarity of Japanese data with Chernobyl indicate the potential role of initial radiocesium speciation in Fukushima fallout. So this is a general scheme of transformation mechanisms for radionuclide speciation, determining its retention in soils and sediments. These processes are controlling radiocesium solid-liquid distribution, its mobility and bioavailability. And this is definition of KD value, and this is so-called exchangeable KD value. The ratio between exchangeable and non-exchangeable forms can be determined using sequential extraction technique. The total of apparent or total distribution coefficient for radionuclides varies in a wide range as a function of fallout characteristics and environmental conditions. The total distribution coefficient for radionuclides is a dynamic characteristics and depends on transformation rates of chemical forms. By contrast, exchangeable KD, this one, can be predicted on the basis of intrinsic properties of soils or sediments, such as selective sorption sites capacity and radiocesium interception potential. After the nuclear accident, contaminated catchments become a long-term source of secondary water pollution. Here you can see heavily contaminated catchments of Dnieper and Pripyat rivers in Chernobyl. This one. This is the Dnieper basin. And Pripyat river is a right bank tributary of the Dnieper river. And you also see the 14 river catchments contaminated in Fukushima area. These are Abakuma, Nida, Ukeda, Maeda, and other rivers. All contaminated Fukushima river flow in the Pacific Ocean. This is the coast of Pacific Ocean. And bring radiocesium from contaminated catchments to the ocean. Observation, understanding underlying mechanisms, and prediction of radionuclide wash-off and long-term dynamics in surface runoff and rivers is a challenge for both Chernobyl and Fukushima contaminated areas. Good illustration of chemical forms and their transformation depending on environmental characteristics is remobilization of radiocesium along the rivers from upstream to the mouth. On the interface between fresh and coastal waters, KD jumps down for 2 orders of magnitude in the coastal waters due to sharp increase of potassium concentration from several milligram per liter to about 400 milligram per liter. Also for about 2 orders of magnitude. Potassium is the major competitive cation for radiocesium. High concentrations of potassium remove radiocesium from the solid phase and mobilize radiocesium, transfer it to solution. This causes ion exchange desorption and remobilization of radiocesium from sediments to solution. Here you can see how it goes for 3 contaminated rivers, Abakuma, Mayeda, and Nida. And comparison with coastal waters in the area. You see, these are KD values in the ocean water, which are about 2 orders of magnitude lower than in fresh water. Therefore, the freshwater sediments come into the ocean, release radiocesium into solution. Long-term dynamics of radionuclide concentration in rivers and other water bodies is quite often described by purely empiric multi-exponential model with fitting parameters Ci and Ki. However, the disadvantage of this model is that its parameters cannot be assessed right after the accident because they are very much site-specific. And therefore, it cannot be used for prediction in long term. Alternative way of long-term modeling is semi-empiric diffusional model based on presumption that decline of radiocesium in rivers is determined by radionuclide decline in the catchment topsoil layer. The advantage of this semi-empirical diffusion-based approach is that all phases after the accident can be described by the same equation with the same physically based parameters, which can be estimated or determined in the field or laboratory studies. So here you can see the map of annual precipitation in Japan and its dynamics during the year. Annual precipitation in Fukushima is 2 to 3 times higher than in Chernobyl and Mayak. Generally, higher precipitation, higher air temperature, and steep slopes in the region of Fukushima promote higher wash-off of radiocesium and faster natural attenuation as compared to the Chernobyl. Here you can see the distribution of the precipitation in Fukushima during the year. These are the data for 2 years. And these are times of typhoon, when the biggest part of precipitation fall down. Significant flooding occurs in Fukushima prefecture during typhoon season, usually from mid-August to October. A very rare extreme flood occurred from 6 to 11 September 2015 as a result of tropical storm Ito, which passed on. During a 6 days period, more than 450 millimeters of precipitation fell in contaminated zone, which is about 1/3 of the annual norm, and which is about the annual norm for Mayak. So, and this was fall down during just 6 days in Fukushima. During the flood of September 2015, water flows washed out unsupported sections of stream banks. Also, some landslide occurred, mainly on very steep slopes. Dramatic changes of radiocesium distribution after the extreme flood event in September 2015 occurred at the site of floodplain of the Hizo River. This is a tributary of one of the important Nida River in the Fukushima prefecture. During the September 2015 extreme flood, contaminated sediments on river floodplain were removed by the flow and were replaced by cleaner sediments originating from deeper soil layers. Both activity concentration and inventory dropped down significantly, which caused substantial decrease of the air dose rate at one of the sites from 6 to 0.85 microsievert per hour. Line measurements, here you can see the line, of freshly deposited sediments after Typhoon Ito showed that sediment deposition during the event at one of the sites was up to 40 centimeters. Here you can see soil core sampling and artificial grass mat installation on the Nida River, floodplain, and time changes of radiocesium distribution in floodplain sediments before and after Typhoon Ito, which is important that the concentration in the top layer decreased substantially due to these floodings, which cause substantial decline in dose rate without any additional remediation, just self-purification or attenuation. This slide demonstrates another, the most recent example of Typhoon Hagibis, which happened in October 2019. The amount of 24 hours rainfall during Typhoon Hagibis in Fukushima contaminated area was up to 400 millimeters and higher. Here you can see the prediction of the precipitation in different areas of Honshu Island in Japan. By the way, this is about, again, annual precipitation at Mayak. And here in Japan and Fukushima, this amount of precipitation fall down during 24 hours, 1 day. These are pictures of Abakuba River, which is actually the basic, the most, the largest river in Fukushima prefecture. During the typhoon Hagibis in Fukushima city, massive flux of contaminated sediments by the river to the ocean took place during typhoon. As shown by illustrations, desorption and remobilization of radiocesium from sediments increased dissolved radiocesium concentration in local coastal waters of the ocean. Essential redistribution of radiocesium on the catchment was expected and happened. Here you can see radiocesium vertical distribution in floodplain sediments deposit at Fukushima city before Hagibis, which is blue, and after, which is red. We suggested that during Typhoon Hagibis, contaminated sediments from Kuchibuta River catchment were transported and deposited onto Abakuma River floodplain. Kuchibuta River flow from the most contaminated areas to the Abakuma River. In frame of the project of technical assistance of Japan to Ukraine, we have a chance to study long-term dynamics and consequences of radioactive contamination in the Chernobyl exclusion zone. For me, this is just return to my work, which I started 35 years ago, immediately after the Chernobyl accident. This slide shows the map of the most contaminated lakes and ponds in the Chernobyl exclusion zone and our soil, waters, and bottom sediment sampling at Glubokaya and Azbuchin Lake, as well as at Chernobyl cooling pond. The Chernobyl nuclear power plant cooling pond is one of the major water bodies that were heavily contaminated as a result of the Chernobyl accident. The cooling pond was used as a reservoir of cooling water for Chernobyl nuclear power plant reactors until 2000 year, when the plant was finally shut down and the cooling pond became no longer required for operational purposes. In May 2014, water pumping from Pripyat River to the cooling pond was stopped, and as a result, the water level in cooling pond began steadily declining and was reduced by more than 6 meters. Here you can see the time changes of dissolved cesium-137 in the cooling pond and its description by proposed semi-empirical diffusional model. The long-term studies of cesium-137 dynamics in the ponds of Akuma town in the vicinity of Fukushima Daiichi nuclear power plant have shown that the concentration of these radionuclides are higher in ponds than in rivers and dam reservoir of the region. The similar conclusion as for Chernobyl, small lakes and ponds. Similar to Chernobyl cooling pond, the highest levels of the dissolved cesium-137 in the studied ponds were observed during the summer. Here you can see the seasonality of the dissolved cesium-137 in these ponds. Additional dissolution of radiocesium in the summer was attributed to temperature dependence of cesium-137 desorption from clay minerals and remobilization by ammonium. A decline in both particulate and dissolved cesium activity concentration was revealed in these studies. The reduction rate of particulate cesium activity concentration was much higher than that for dissolved. Therefore, slow remobilization of cesium-137 occurred in ponds in time. We hypothesized that this remobilization may be associated with decomposition of glassy hot particles and subsequent leaching of cesium-137 from these particles. There are deep reservoirs on many Fukushima rivers, such as Yokogawa Dam on Ota River, Agaki Dam on Ukeda River, and others. Similar to Mayak and Chernobyl, the reservoirs in Fukushima area play a role of the traps for the contaminated sediments. Bottom sediments deposits in accumulation zones can be used for reconstruction of long-term dynamics of particulate radiocesium in correspondent rivers and lakes. Here you can see the map of such a dam reservoir, the most important ones. And here you can see the collection of bottom sediment cores. These are the cores which are sliced then and studied. Here you can see the similar situation in Chernobyl. You know, the Dnieper River in Ukraine has a cascade of 6 reservoirs, and all of them play a role of trap for radiocesium and prevent the migration of radiocesium to the Black Sea. So here you can see the similar situation in Mayak. However, in Mayak, the trapping of radionuclides by reservoirs was used to remediate the Techa River, which was severely contaminated by the dumping of radioactive waste. And here you can see the historical development of the situation. These 2 reservoirs, reservoir number 10 and reservoir number 11, were constructed to prevent the dispersion of radionuclides from these sites. Actually, from 1949 to 1956, the intermediate radioactive waste, liquid radioactive waste, was dumped to reservoir 3 and reservoir 4 located over here. Then they started from 1951, they started to dump this radioactive waste to Karachay. In 1956, the first artificial dam reservoir was constructed, which is reservoir 10. And this construction decreased substantially the outflow of radionuclide from the site. Therefore, in 1964, one more artificial reservoir was constructed, which is the reservoir number 11, to reduce even more the concentrations of radionuclide. So these two reservoirs were purely constructed to stop migration of radionuclides through the rivers. This slide just illustrates in more detail these two reservoirs, number 10 and number 11. And these two reservoirs, R3 and R4, were the places where the dumping of radioactive waste happened, let's say, back 50, 60 years ago. And here is the scheme, how the Teche River, then how the radionuclides from Teche River then flow up to the Opi River. So here you can see the vertical profiles of cesium-137 in bottom sediments of dam reservoirs for both Chernobyl area, this one. This is a Shokino dam reservoir in Russia, and Fukushima. This is the bottom sediments core from Agaki Dam on Ukeda River. These profiles have been used for reconstruction of radiocesium dynamics and comparison with monitoring data. The maximum of this profile corresponds to an initial point of the deposition, sediments deposition. Therefore, this maximum corresponds to 1986, and this one to 2011. And therefore, in case of such profiles, we can reconstruct, we can, let's say, divide all this profile to the years and calculate what was the concentration, particulate concentration of radiocesium in specific period of time. And here you can see the reconstructed time dependence of dissolved cesium in becquerel per liter for Shokino Dam reservoir. This is for Ukeda River on the basis of these profiles and results of modeling. We also use the same approach for Glubokaya Lake and other lakes in Chernobyl exclusion zone. Here you can see the particulate and dissolved cesium-137 wash-off ratio, which is actually the normalized concentration of radiocesium. Radiocesium in becquerel per cubic meter, normalized by the deposition on the catchment in becquerel per square meter. Therefore, the unit here is inverse meter. So these wash-off ratios were reconstructed from the core of bottom sediments in Agaki Dam in comparison with monitoring data for Ukeda River and Agaki Dam, as well as with related Chernobyl data. Particulate wash-off ratio is comparable for Fukushima and Chernobyl. However, dissolved wash-off ratio is at least order of magnitude lower in Fukushima than in Chernobyl, mostly because of higher values of distribution coefficient, which we already discussed before. So the main messages of my lecture, the most important points. First, Fukushima-derived radiocesium is strongly bound by soil and sediment particles as compared with Chernobyl, Mayak, and nuclear weapon tests origin radiocesium. This promotes faster scavenging of radiocesium in surface waters and prevailing transport of radiocesium on suspended material with surface runoff and river flow. Second, higher precipitation in the Fukushima region, steep slopes, and higher average air temperature promote higher washoff of radiocesium as compared to Mayak and Chernobyl cases, and faster natural attenuation or self-purification of contaminated catchments. Extreme flood events during typhoons result in fast and efficient redistribution of radioactive contamination in Fukushima. Similar to Mayak and Chernobyl, dam reservoirs in Fukushima play important role of traps and prevent radiocesium transport downstream. At the end of my lecture, I would like to advertise our book series, which is called Behavior of Radionuclides in the Environment. 2 first volumes of the book have been published by Springer last year and were devoted mainly to Lake Karachay at Mayak, Russia. This is volume 1. And to Chernobyl. This is volume 2. By the way, our co-editor of these 2 volumes is a dean of chemistry department of Moscow State University, Stepan Kalmykov. Volume 3 of the book will be devoted to Fukushima and should be published in December this year. So thank you very much for your attention, and I will be happy to answer any your question if you have some. For your information, you have here the reference to the website of our institute, where you can find much more detailed information about what we are doing and so on. And this is my email. If you have specific questions afterwards, please welcome. Don't hesitate to ask them. Thank you.
Thank you very much. Do you have questions? Yeah, please. Yeah, okay.
Thank you for the nice presentation. My first question is about slide 12, please. Slide 12. Slide 12.
Alexei?
Hello. I didn't catch the question. Could you repeat it?
Okay. Thank you for the nice presentation. And I want slide 12 to ask my question.
Slide 12.
Yes.
Okay. Okay. Just a moment.
So, my question is about that cesium is stronger bound to soil in case of Chernobyl more than Fukushima. That maybe depend on the kind of soil composition. This may be based on the soil composition in Chernobyl compared with the soil composition in Fukushima.
Yeah. Okay. So radiocesium in Fukushima soil is stronger bound to soil particles than in Chernobyl.
Yes.
This is because of, we believe, this is because of two reasons. First of all, soils of Fukushima contain more clay minerals,
Yes.
and especially more micaceous clay minerals, which are known to selectively sob, strongly sob, and fixation means transfer of radiocesium to non-exchangeable form. Sometimes it is called irreversibly sorbed form, but it's not irreversibly. It's a reversible process, but reverse process of remobilization is very slow. So the steady state of non-exchangeable cesium is very high. So, and Fukushima soils are characterized by high fraction of these micaceous clay minerals, and therefore high ability to sob selectively and fix, strongly bind radiocesium. This is one reason. Another reason is that, so in all contaminated areas, there are glassy hot particles. These glassy hot particles are insoluble in water. This means they are not involved in the exchange with water. Yeah, so they somehow demonstrate that cesium is bound by these particles. So two major factors.
Yes. The second question, I think slide 29.
29.
I think
Yeah, by the way, this is the picture which can, let's say, illustrate what I answered.
Yes.
You see, this is non-exchangeable form. This non-exchangeable form is not involved in exchange with solution. Only exchangeable form can be dissolved and transferred to solution. This non-exchangeable form is not involved in this. So this non-exchangeable form contains hot particles. In case of Fukushima, glassy hot particles. In case of Chernobyl, fuel particles. However, with time, these hot particles decompose. And as a result of this decomposition, radiocesium transfer to solution. But this process is very slow. Time scale of fuel particles decomposition and leaching of radionuclides from them is about 2 years, 2 to 10 years. Time scale of glassy hot particles in Fukushima is even longer, more than 10 years. So this is very slow process. At the same time, there is fixed form by micaceous clay minerals. What is the mechanism? Again, you see, this is the scheme how cesium is selectively sorbed by these micaceous clay minerals. You see, this is the layers of crystal lattice of micaceous clay mineral. Normally, they have potassium here, but in solution, when you have the water, potassium can, let's say, leave this place. And therefore, this plate get additional negative charge. This also. So two negatively charged plate so tend to, let's say, move from each other. And therefore, they provide some specific places. However, cations like calcium, magnesium, even sodium, they have very high hydration energy. And they are not able to lose the molecules of water to penetrate to these places. And specificity of cesium that is that first, cesium has low hydration energy and can lose this sphere of hydration molecules of water and penetrate to these places. Another specificity is that the size of dehydrated cesium is very well fitted with these, let's say, sites. And therefore, the selectivity of these sites to cesium is the highest as compared with potassium and ammonium. Only potassium and ammonium can also penetrate to these places. However, the selectivity coefficient of cesium as compared to potassium is 1,000. This means that 1,000 times cesium is more preferable for these sites than potassium. And selectivity coefficient of cesium as compared to ammonium is 200. This means that ammonium is 5 times more capable than potassium to replace cesium on these selective sorption sites. What happened? What is the mechanism of fixation of radiocesium on these sites? So this expanding of the layers is very dynamic. Sometimes this negative, additional negative charge can be neutralized by potassium or any other cations. And therefore, this fried edge site collapse. So they collapse and cesium became inside the crystal lattice. And therefore, it is not able anymore to transfer to solution. It's getting fixed. Okay?
Okay, thank you very much. Also, I have obtained my second question answer from your illustration. Thank you very much. Thank you.
Yeah, okay.
Thank you. Next question. Yeah, please.
Slide number 11.
What?
Slide number 11.
11, okay. This one.
Yeah. So, with respect to cesium, if we take on 11th March 2011,
yeah,
on that night, in Sagamihara, in Fukushima Prefecture, there was snow. The whole night there was snowing. So when this blast happened, the power plant blast, most of the contaminant were exposed to the atmosphere.
Yeah.
They were precipitated because of the snow on the soil. That is the first factor of mobility.
Yeah.
After typhoon, Agahimara, Mawara, this river, that gains the secondary which can collect and transport and feed it to the ocean. So up to 2015, the soil has the higher concentrations because it was the precipitated from the day of accident till 3 to 4 days. There was continuous snowing. So it was absorbed by the soil at first, and because, as you say, micaceous clays, they have good porosity and permeability, so they absorb that things. Whereas when the typhoon came, they washed out surfacial runoff, then they feed it back to the ocean. But this mobility factor, if we compare to the Chernobyl, the Chernobyl mobility factor is wind. If we get in UK, in Berlin, in Germany, we have also certain mushrooms where we found cesium and strontium. So the mobility factor is completely different with respect to Fukushima and Chernobyl. That completely make the whole scenario that why Chernobyl has highest concentration far away in the west, whereas Fukushima is locally, regionally settled. The mobility factor plays a dominant role. At the time of Chernobyl blast, it was wind, westward wind, whereas Fukushima, it was snow, localized snow. So these two scenarios have a bigger impact of mobility in a compare and contrast view.
Yes, you are right. Let's say what I understood. I will give you few comments. First, this is extremely important. The season when the accident happened, when the release happened. If you have snow cover, this will be one case. If you don't have snow cover, this will be another case. In principle, in March, normally for the most of the territory of Fukushima prefecture, there is no snow. Snow cover is very unstable in Fukushima prefecture. And in March, normally there is no snow, but as you see,
but 2011 in March, first week from 2nd or 3rd March up to 13th of March, there was snow. Fukushima,
yeah, there was snow, but this is this snow has not established the stable cover.
No. I mean,
but
they help to settle down on the all exposed, where all the blasts were exposed to the air. Those were settled down and they have gravitatively they settle on the soil. Starting up to 13th of March, there was very slowly snow up to Sagamihara and Fukushima prefecture, middle east coast of Japan. There was slow snows. I witnessed that, and they are enough to settle down the all aerosols exposed to the air on the surface. And cesium remains 4 to 5 years, but after that, like you explained, typhoon came. Then they surfacially run off and go to the main river and then feed it to the ocean. East part of the ocean.
Yeah, you're right. Actually, if we are talking about the water bodies, so first we should distinguish between direct deposition of fallout on the surface of the water body, and this is why this deposition is let's say maximum value of the concentration in the water and then in the bottom sediments. So after this initial stage, the most important source of radiocesium to water bodies and then to the ocean is the wash off from the catchments, because the precipitation from the surface runoff, sand face runoff brings, let's say, particulate and dissolved cesium and brings it to the rivers, and the rivers flow to the ocean.
Yes. So this was just my request to that we have to add at the time of accident, what was the atmospheric condition and what is the you already mentioned one parameter, that was micaceous soil, which has a very good property with high porosity and permeability to absorb and hold. That was very good factor which was missing in Chernobyl. But Chernobyl has a wind factor, westward wind, whereas in Fukushima that was a localized regionally snow, which helps to precipitate on the soil the the blast particles.
Fukushima release of iodine and radiocesium
Yes.
was detected by many countries. So it doesn't, so the Fukushima release was also transported over the globe, and it was detected by many countries in Europe, in the United States, everywhere actually the release. But release of Fukushima was much lower than release in terms of cesium and particularly strontium and so on. And therefore, so the long range transport existed, and radionuclides transported by this long range transport, they were detected by monitoring system of many countries. So it was detected in Russia, France, Germany, everywhere, no problem. For monitoring modern monitoring systems to detect the release after the Fukushima Daiichi nuclear power plant. However, the consequences, of course, were much weaker as compared with Chernobyl. You know, after Chernobyl, there were a lot of measures taken by many European countries. Until recently, there were bans for, let's say, for the agricultural animals in UK, in Germany, in Austria, in Norway for raw deer. So because of food chains and because of transfer of Chernobyl radiocesium to the meat of these animals. So in case of Fukushima, we can say that transboundary transport was not important at all. So, however, everywhere the release was detected. No problem for modern monitoring system to detect such, let's say, concentrations of radionuclides. Okay?
I'm sorry, I want to 5 minutes probably. Please explain a little bit how a dam can stop and protect the transmission of the radionuclides. How because in Russia it happened. There are 2 dams you mentioned. Can you please explain?
2 jam, I don't, maybe.
The dam.
Dam, okay.
So how the dam can stop the transmission of radionuclides in the river? How?
Okay. Many radionuclides, especially such as radiocesium, ruthenium, cerium, plutonium, americium, and so on, they are strongly bound with particles. What dam is doing? Dam accumulate sediments because dam reservoir, this is a big area of sedimentation particles. And these particles stay in the reservoir and don't go farther with the river. At least any dam reduce substantially the penetration of sediment particles and associated with these particles radionuclides. So in terms of binding only strontium from ecologically important radionuclides. Strontium is the most weakly bound with particles, and therefore strontium migrates quite, let's say, efficiently. And this is the point, a special point for Mayak in Russia, because strontium is one of the most important, let's say, contaminant there. And with Techeriva, strontium migrates quite efficiently, and much more efficiently than cesium. Okay?
Yes, sir. Thank you very much.
Okay. My pleasure.
Thank you very much, Professor Knopfler. So now we will have a short break, and we will continue in 10 minutes with the next lecture. After the final. Вот
Thank you very much.
скопировано.
По видеосвязи? Да,
Чай, кофе?
Вот это, да.
Да, без проблем. Хорошо, так, а вот оно получается. Все, я он идет. Все, давайте тогда я туда подъеду. Да. А он до какого числа? Просто говорит, прилетел,
Ты очень занят сейчас. Ой, господи, не понос, так золотуха, кошмар какой. Да, у меня замечательно глюканул компьютер, и слетели все мои папки, все мои настроили. У меня просто гол как сокол. Мне нужно восстанавливать систему. Я попыталась поковыряться сама, но я не умею такие вещи делать. Но у меня сын это может сделать ювелирно, но не раньше часов 8 вечера. Все, у меня пустые папки все. Документов нет. Что случилось, не могу понять. То ли вирус какой-то словил, то ли еще что-то. Все слетело в одночасье. Ну да. Ну, мой драгоценный отпрыск с этим справится на раз. Я недаром его рожала и воспитывала, да. Если информация сохранилась, но я ничего не сносила, да. Он просто перестал распознавать моего пользователя, пустил меня под моим же паролем ко мне же администратору, но ни одного документа нет, ни одного входа нет, ни одного, ничего нет. Хрен знает, что произошло. Ой, кошмар. Рублей? I've got a problem with my computer. I've got a problem with my computer. At the moment, I have no access to my Google email address and Indeed. So basically, just a moment.
Accept my
Just a moment. Okay. So I talked to Rosatom guys. So they didn't promise me a thing, but they asked me to send a draft. And after that, my computer collapsed. So I will have it repaired, but the main person I talked to, he's at the moment in Tomsk. Never mind, even though I will send him, you know, in my... What you have misunderstood? Okay, so you asked me to help you with your recommendation letter, right? Right. So I received a draft from you, right? Right. So I had to edit it, right? So I prepared for that. So I collected some recommendations letter in order to compile one, natural one. And I gave a call to Rosatom colleagues and asked them whether they will be able to sign it together with us. So they didn't promise me anything, but they would like to look at the letter, okay? Okay. So, and in 10 minutes, my computer collapsed. So I have no access to my Google email address. I have no access to my Yandex email address. I can't spot a single document on my PC. This is a problem which I'm supposed to solve tonight, but not earlier than 8 p.m.
Never mind.
So this is very misfortunate situation for me, and I'm a bit tense because either I will repair my computer or not. If I will not repair it, never mind. Andrei has access to our Google email address. So anyway, we will find a draft of your email, and we will rearrange that. Maybe that will take just more time. That's it.
Excuse me about something email was for me. I say keep in mind. I don't mean anything to misunderstand about me. I mean, be aware of that. But maybe
exactly. So you know, first of all, maybe
that sentence.
Maybe during our communication, you found out that I'm a very responsible person. I never forget anything. I never miss any detail. It's enough for you to tell me something once. If you don't have the results so far, it doesn't mean that I do nothing. I do, I remember, I bear in mind, and certainly I will do something. Once I have a result, I will come back to you. So there's no need for me to remind.
I contacted you from Egypt about 20 emails between me and you. So your first person I contact you.
Okay.
Before I come to Russia. So never mind. Only this position I told you before. Only I'm interested in this position. So I do what I can. Not more. However, excuse me for this sentence. I don't mean keep in your mind that I am not developed. That I am not developed to say that. I mean, be aware that not more. It was one person told me that sentence is not accepted in any email.
Which one?
Keep in your mind that's false, not accepted.
Keep in mind?
Yes. I mean, take care or be in mind, not more. I think you are angry about this sentence. Not more.
No, I'm not angry. I just would like you to understand that I do remember what I have promised you.
Yes.
And I will do whatever possible. And I remember about that, right? The only thing that I didn't do that before, just because I'm limited, right? I might have some technical issues right I'm experiencing at the moment, okay? That's it.
Hope to visit Egypt. Do you obtain my card? My card?
Yes, I would like to have one. Thank you so much. Yes, please. So you would like to have all the lectures? So, but you have the link to the playlist, right? Have you got it? And I believe that from the very beginning, you can watch them, you can rewatch them, except for the very first time. Like that, very okay?
У нас сейчас закупки стоят, вот сейчас приходим, у нас закупки стоят на марку.
This alone, I need to learn.
Я думал,
Просто не знаете, как это Марк не уверен, но февраль тут же. Так, по чуть-чуть познаю себя.
Usually we cite human mind. Usually it's not in that direct way. Yes, what for my business correspondence we usually use like this. Please kindly bear in mind. Please kindly bear in mind. Please please. It's always good to mention please as many times as you wish. If you ask for something, please is a soft.
I want to include that this sentence in Indian is not to say that
Yes, that might be, but you know, I missed something. I don't think that's special.
Из Африки,
Absolutely not. Because of your
это Росатом относится, да? То есть это
как бы Росатом дает деньги на то, что они приезжают. Гостиницу, да, Росатом. То есть, как бы Росатом хорошо, что это под золотом МГТ, что это международное.
Нет, ну к МГТ это все равно имеете, да?
Ну, при этом они спонсируют деньги.
Ну, это хорошо. Это хорошо. То есть, фактически те страны, куда Росатом хочет влезть.
Да. Ну, не все, потому что...
Ну, понятно. Но у вас будет теперь на регулярной основе.
Ну, это я думал, да, что... Я думал, вообще сразу будет что-то интересное.
Ну, интерес есть у них? Есть интерес?
Да, да. Ну, просто здесь... В этом году подобралось так, что мы вынуждены будем искать людей, которые могут физически приехать. Да. Поэтому, например,
понятно, то есть они отсюда внутренне наши.
Да. То есть они
не пересекая границы, да. Молодцы. Правильно, про 2 недели выйдем в Москву.
Да, тут его.
Ну, дай бог, чтобы пошло, да. Поэтому, ну, Росатом сейчас на культуру подписывается, потому что я, к сожалению, отказался сейчас от участия, был номинирован, и доклад был в Италии на следующей неделе будет как раз по обучению. А у нас же как-то центры компетенции. Доклад был принят, но сейчас вот реально из-за этих пертурбаций с новыми с отчетами совсем физически немножко. Я думал просто прийти, а мне позвонили из Росатома, они хотят всю делегацию нашу оформить в ТЗ, для этого нужно было заранее на русском языке все доклады, что на английском я быстро сляпал и все. А такого заранее подготовить на русском, а заранее оформить по ДТК, поэтому думаю, нет. Но там тоже какая-то движуха есть. Там Патрик Сулливан сейчас этим делом. Хотя странно, потому что я общался с этой, с Олесей Николаевичем, да, и с Татьяной, сейчас забываю фамилию, Килочицкая. Она сотрудница Олеси. То есть она на Украине была, ее сотрудница. А это запрещено вообще. Тем более там из одной страны запрещено быть, а тут к тому же они безопасники, все-таки регуляторы, пришли в технологическую секцию. И вот так вот. А там сначала приняли Татьяну, а потом уже по 5 это уже дипломатический пост, там уже и приняли потом и Налей. Да, конечно.
So, dear colleagues, we are going to just continue our
Okay, guys, please do continue your information calls. You please find
This is in Moscow, yeah?
Sorry?
This is in Moscow, BNIAM,
Yes.
the Metrology Institute. Metrology.
Yes.
Yeah?
It's also metrology. Yes, we have so it's a very big institution.
Yes, I know. May I have the visiting card?
Today, no.
Okay, I can take your email address.
Yes, you have. I think. Okay. Now I can write now. Email. Okay, good afternoon, ladies and gentlemen. Are you ready?
Yes.
Yes. Okay, today we'll speak about the contamination of contaminated soils. First of all, I would like to say that the contaminations of soil every time, I'm sorry. Every time contamination of soil is a result of accident, because in normal operation of nuclear facilities and of any of the nuclear facilities, we have not contamination of soil. We can have a contamination of equipment, pipes, etc., etc., etc. But the soil is contaminated just only as a result of accident. So the first information about fundamentals of for the contamination, we should note that immediately after accident, radioactive materials contaminated surface, and for deep depth approximately 1 to 3 or 5 centimeters. It depends on the type of soils. But after, as a result of different processes of chemical exchange and physical processes, the contamination of soils penetrated deeply into soil, and for full decontamination of soil, we need to remove the much more materials, up to few centimeters or more, and it depends again on the type of soil. So you have the cross section of soil layer with different types of soils, with different types of chemical and physical abilities. What is the driver for penetration of radionuclides into the depth of the contaminated, or in the depth of contaminated soil? It is different processes, mainly as a result of penetration of water into the depth of soils between the, and in this case, and water penetrated into the space between soil particles, and also transported to the radionuclides into water solution form into the depth of soil. Then the penetration of radionuclides also depends on type of soil, of chemical composition of soil, pH of soil, and a lot of other factors included for speed of penetration of radionuclide into the depth of soil. And what is more interesting for us for understanding of mechanisms of preparation of soils and radionuclides, it is nature of minerals, because primary minerals like the soil, it is a result of destroying during crushing of the initial materials, and it is resulted of practically all composition is a result of quartz. And the quartz is a very interesting mineral, and it has very small specific surface of this area, and so incorporation of radionuclides into the depth of quartz particles is very small, because it cannot have the physical abilities to penetrate into this into the depth of quartz mineral. But other materials like clay or silt are very penetrated for radionuclides, and so in soil composition we can subdivide it the more contaminated particles. It is particles of organic particles, because in this case interaction between organic material and clay materials are very good, and its result is like chemical reactions, not physical interaction or physical functions. But also we should remember that on the surface of minerals, both clay and quartz and sandy soil, we have the small negative charge. And this charge arising as a result of leachability of materials from the surface of material minerals, and so this, all these soil particles, especially the clay or organic particles, are very good for incorporation of radionuclides, which have the practically positive charge. So it is electrochemical interaction, absorption, and chemical processes, complex complexons, etc. And so in this condition, and we have here you see the result of leachability of the surface, because on the surface you have the small particles of with negative charge, OH and the COH minus. And so this flow diagram for the penetration of radionuclides through the soil. All chemical and physical processes are created within this interaction, and so also you see this mobility. This table contains the information about radionuclide mobility inside the different kind of soil and the different radionuclides, and depending on the soil. It is very important to note that, for example, as a result of Chernobyl accident, it was noted that mobility of strontium much more than mobility of cesium, and instead different size for the diameter of the size of strontium ion is more than diameter of cesium ion, but mobility of strontium ion is much more than cesium. Excess, and so you see plutonium is less mobility, etc. We will see this later. So, for the contamination of soil, we can subdivide it for two big groups of methods or technologies: in situ, without removal of soil from surface, or ex situ, with removal of soil from the surface and the transportation to the treatment facility, then treatment of radioactive materials with radioactive materials. So, very different methods of we can subdivide remediation and decontamination as different processes, but very often it's used together, remediation method and the decontamination method. So for decontamination of agricultural lands, like in the area around of Chernobyl or around Fukushima, it's possible to apply soft remediation methods, which are pluging, water repellent, and this method is applied for relatively low contaminated area, and the basis of this process is just only water rotate this contamination from the top layer of soil into the depth of soil. But it's possible to apply just only if we have this low level contamination, because we will have higher levels of contamination. Will contaminate the all big layer of soil, because pollution penetrated up to 30 centimeters, so up to half meter special cases, and practically the process is dilution of contaminated materials with clean soil from the under. And the strong remediation methods, all methods includes the removal of soil from surface and the treatment of the by special technologies and facilities. Washing method also includes in this group of methods, or strong methods, and very interesting two methods in situ remediation. It is heat remediation method and biological method. I will speak about heat remediation later, but biological I will not discuss it in this presentation, because it does not have very deep application, and it's possible to use mainly for soils contaminated with uranium or plutonium, because during the biodegradation of strong complexes, uranium and plutonium has a more mobilities into the soils, and so after bioremediation it's possible to remove uranium and plutonium into different kind of solutions. So here you can see the very simple methods of removal of FLAO soil, it is mechanically or handy methods. Just only remove 3, 5, or maximum 10 centimeters of soil. Of course, in this case, result of these activities will be very, very big amounts or volumes of contaminated soils. It's all these photos demonstrated activities in the area, and you see contaminated soil accumulated in the big bags, and then these bags will store in special sites. Normally it was I visited Fukushima area three times, in 2011 and 2012, and all these big bags accumulated in the big areas and directly under the atmospheric precipitation. So it was again a new distribution of contaminations from these big bags. Here it is deep wooding, you see different methods of wooding for the surface. So this method for remediation of not highly contaminated areas. So here initially it was applied from Soviet Union after accident in Ural 1957, when a lot of agriculture fields were contaminated with cesium, strontium, and also transuranium materials. This Eastern Ural plume. This information about different methods for decontamination of soils was tested by MAP, because this activity was happened in 2011 and 2012 in Japan. You see different decontamination factors for different methods, and now we'll discuss methods for special treatment of soils contaminated with radionuclides. First, a very simple method of decontamination is segregation. We can notice the different types of segregation. Segregation by radioactivity, density, or size. More easy to segregate contaminated soil with by the radiometry factor. So you see here this photo is from storage facility for old storage facility of Korsakov Research Institute in Moscow. It is a photo of contaminated materials, which can so you can see if we will remove the mainly contaminated parts in the right here. This photo you will decontaminate practically all this volume of radioactive materials. So, and the main and really worked methods of segmented gate system was developed for project of DOE in the United States, and applied in Albuquerque laboratory for segregation of contaminated materials. It is very simple flow sheet of diagram of this method. Just only conveyor and the detector. Of course, when we have the soil should be planar with one thickness, because it depends on activity and depends on the layer of the soil. And if you have a peak of activity, this should be detected by detectors, and the mechanism should be more rotate the second conveyor from the clean material to contaminated materials. Very easy system, and it's worked few years. I sorry, I miss the real photo of this method. So, But this method, by this method, was treated a few thousand cubic meters of material, contaminated materials, and it's really very easy. But it's very old experience. Now this experience repeated practically, but in a different design. Into the Bogunice power plant for the commissioning purposes of all the facilities of Bogunice. A1 accidental unit and A2. So, chemical extraction method of ex situ. This method is like in situ extraction of uranium ores. So it needs to apply strong chemicals for dissolution of radionuclides from the soil surface. But in this case, we need to treat it into different tanks or special equipment for preparation of ability to collect all dissoluted materials from these chemicals. So we need to treat this soil with chemicals and special solvents and all complexes. It depends on purposes. So it is very flexible method also, but it needs a lot of special chemicals and of course a lot of secondary waste. And it's more important than that all soil after this kind of treatment will not be really soil, because it will be only chemical materials, because the soil is very special materials, very suitable for microbe, for biological materials, and after treatment with strong chemicals, of course, all the abilities of soil will be went to the zero practically, and so it is will be not soil, but only materials, not ground, only chemical materials. No, next very specific method of treatment, in situ vitrification. It was tested just only one time, but it's very interesting method. Just only one time in Australia, when this method was applied for localization of former weapon test site, for localization of radionuclides inside it was underground explosion, nuclear explosion. A lot of activities comes from 4.0 of this explosion, and it needs to localize. So, yes, practically, because you see temperature is more than 1000 of centigrade. And it was formed, no, it is not glass. You see, it is like volcanic glass.
Glass exactly. Flexible, radioactive light site.
Yes, and it is all these contaminations incorporated in this big aggregate. It was practically glass on site. Of course, disadvantage of this method is very high needs in the electricity. Of course, it's not just only location of graphite electrodes inside ground, and then apply the very high electricity. So for enough for melting. So you see, it is very no, it's not economically reasonable method, but it's very interesting for localization of real.
That's why people use underground
Onion.
onions, on some onions, official test, window test.
I don't know. I'm not ready to answer now. So it was treated practically 11 kids after the explosion. So it was successful. So heat extraction. It is really worked method, but this method works very slow. The base of this method is transport of soluble form of radionuclide from the soil to grass system, grass or herbs, possible to apply the different grasses because the different grasses has different abilities to interact with soluble forms of radionuclides. And so we can apply the special grasses for accumulation of radionuclides from the soil. But the distribution factor is very, very low. So we need to a lot of years for rotation of radionuclides from the soil to the plant. And more important, for decontamination, you should be ready to remove grass or plants every year after the vegetation period. So a lot of this method produces a lot of secondary biological waste as a radioactive material. So it is possible to apply, but not so widely. Just only know about experience of in Belarus, Borneo region, but I think there is data from this experiment. And more interesting methods, next which developed myself with our team in Moscow Institute of Mining, we developed a soil washing process or adexpiration, which is the same name. It is very simple methods, but not least that these methods applied very effectively for sandy soils. I will speak about later, but this first technology is good, very good for sandy soils. For different kind of soils, for clays with high clay content, it is not so effective because clay should be removed from soil for decontamination. But if you have a lot of clay, you cannot remove it from soil because it is the contamination factor will be low. So, first of all, we discussed this ability from this table and next also. You see that mostly activity incorporated to a small fraction of soil. So it's accumulated by small fraction of soil. It is particles of clay. So this another data, this data from our experiment in Moscow. So also we see the smallest part of particles has a higher part of activity. It is it's possible to explain like this from this photo. You see the small black particles. It's like contaminations. So it's aggregate of the biggest particles. You see the scale is 10 microns, approximately 2 times in terms of microns. And the smallest parts, including incorporated onto the particles, we will discuss it or the ability to interact by electrochemically with the surface of this big particles, or incorporated between these particles. So water media can remove the smallest particles from the soil, and if we will remove the small particles but highly contaminate, we will decontaminate the process. So, first of all, we need to remove the soil from the surface and transport it to a special facility, and then especially treat this soil for better distribution, for better small particles from the big ones, and classification of mineral fraction from this water, soil water dispersion from this bisides. So smallest fraction will be contaminated fraction. So this is the diagram of flow sheet of our methods on Russian scientific magazines. This distribution of the soils starting from this top of this diagram. The first of all, it will be melted like meals into a scrubber, water scrubber, and the scrubber special Russian scrubber butter. I don't know it in English. So after extraction of soil in water, it should be segregated much more into the screw mechanism. This segregation of medium size with factors from less than -3 or 1 for 0.1 millimeters. Then the smallest particles comes to the tank for sedimentation. In this tank, we will add it special polymers. So next slide. This polymers interact with negative charge onto the surface and sedimentating because we have a big conflict between two positive charges and negative charges of polyamine and polycation, and all this conflicts is sedimented with small soil particles, and we have purification of water by sedimentation. And then we can remove these small particles. Then last stage is dewatering of this sediment, and this dewatered state is practically contaminated radioactive waste.
So what about stones?
Strontium also remove these particles because strontium has abilities to solute from the surface, surface, but much more strontium includes into the surface by chemical reactions, so it's chemical sorption. So we can remove this both, and particles is contaminated with strontium and cesium, and much more important for us, plutonium and uranium. But also strontium and cesium can accumulate it in the water.
So the impotence,
Yes. Yes. Chemical, and next we'll demonstrate this chemical mechanism of sedimentation, and also the strontium can incorporate in this metal polymeric polymers incorporated, because here you can see practically it's like data system, because polyanion and polycation can interact directly with formation of stable and water-insoluble complex. Polycation and polyanion. Polycation. Cation. Negative, positive charge.
no, that is clear. Polycation, polyamide. But what is P?
P is polyelectro complex. Polyelectrolytes. It depends. We developed these polymers initially for gas suppression for Chernobyl after Chernobyl accident, because the mechanism is the same. Yes.
Is it geopolymer or synthetic?
No, it is not geopolymer. No. It is synthetic polymers. Yes. It is very. It has a good interaction between negative charge with soil. The first of all, that the polycation particles and soil particles. But it's water soluble. Polycation and polyamine are water soluble. So, polycation or polyamine in this composition, it will be created in water insoluble polyamine. So it is very good work for like flocculants, and we need just only a few milligrams for purification of clean water. And like here, you see that is purification of water. You see the A is after application of flocculants, B without flocculants. So it is very good sedimentation process. So this is another diagram of this method. And this technology was developed for Kurchatov Research Center, Kurchatov Research Institution, because in the beginning of 2000s they remediated all the storage facility, and the result of activity of many years, of 50 years of activity of Kurchatov Institute, the soil was very contaminated. But fortunately, the territory of Kurchatov Institute located in the area of sandy soil, and so we offer this very simple method and applied for decontamination of this territory. So next slide will describe this real technology, real installation operated approximately as a result more than 7 years, because initially it was designed like a pilot plant for capacity of 2 tons, 2 cubic meters per hour, yes, 2 cubic meters per hour, but it was after some modifications, it operated approximately more than 7 years, and treated like you see more than 10,000 cubic meters of soils with efficiency decontamination factor 5 without the decontamination factor. So it is very big difference because it was normal practice Kurchatov Institute planned to transport all 10,000 cubic meters of sand or soil for storage facility in Sergei Posad, it is in Radon site, for direct storage into containers without treatment. But after this treatment, they need to transport just only 2,000 cubic meters of radioactive materials. As you understand, treatment and transportation of big amount of radioactive waste into Moscow region and this region of generation, it is very difficult. So this process was very effective, not only by finance, but also like social and ecological factor.
So this is low.
It was a low level waste because contamination was not so big. A few spots were contaminated, but mainly the soils were not so contaminated. So medium level was a low level waste, low level contaminations. You see, it was also segregation by few different particles. You see, and here you see Debris accumulated one container, it's practically clean soil with medium fractions of soil, and just in this step, after the watering was accumulated as radioactive waste and storage facility. You can see this design of this installation. The first view is first photo during the process of fabrication of this facility. It is a relatively big facility. For its placement, it was needed a special building, temporary building, but it was a good result of application. Results, so you see also here. It was very important to know that the contamination factor for this technology was reached 5. It was really good contamination factor for this facility, but we offered also to make a better result. This ultrasonic treatment of the soils, but when we tested it in our institution, in laboratory conditions, we reached a really good contamination factor up to 15 or even 20. But for logistic purposes for Kurchatsk institution, it was enough the contamination factor in 5, so design pilot plant for ultrasonic treatment, additional treatment of tech after all this system. But it really possible and we can recommend it. So this is not final result because it was treated just only 6,000 cubic meters, but you can see here its distribution. Here it's not right photo. Of clean and radioactive waste, clean soil and radioactive waste. I'm
So
sorry, in English, in
So
Russian.
this is a scenario of low level waste, yeah?
Yes.
Because 10% is merely, it's incredible.
Yes, really. I'm sorry, it was in Russian. This is efficiency after the ultrasonic decontamination. So the alcohol decontamination factor reached higher than more than 30. This was much more than 5, but it's not neat. So, but because the needs of application of different techniques for soil washing needs this method is very applicable for decommissioning purposes, and you know that Rosatom developed a special program of decommissioning of old and legacy facilities, and so the second generation of this facility they were designed later, and the main difference was placement of this all this equipment for mobile version. For mobile unit, mobile it means it's possible transported by trucks and combined on site for treatment. And this facilities were built on constructed also the same team and the team of Radon, Moscow Radon, and but the capacity was less, approximately 1,000 kilogram per hour. It was enough for mobile version, and it's combined into 6 different sections, so 6 modules: scrubber model, classifier model, contact watts model, thickener model, filter model, and cake examining model. And actually auxiliary equipment, it is water supplies, ventilation system, preparation of polymers for sedimentation. And so you see this mobile unit now assembled into our institution and tested for different purposes. For decontaminate, it was treated some, I think, 70 cubic meters of radioactively contaminated soil into our institution, because our institution during the very long history contaminated a lot of rooms, laboratories, but not only in laboratories, but also territories, so on its own territory. And so you see there's a combination of different models, this description of all parts of this equipment. So I will not stop here, just only demonstrate its different view of this installation. Description you will find it later in your memory stick. And so this is sedimentation tank, which includes also the line of preparation of chemicals. And the last step, which is the watering system. It's just only press filter for compaction of cake and for the watering. The full diagram of this installation, but I'm sorry, all signs in Russian, but you can see it's the previous slides. This is the result of tests. Yes, experimental decontamination of 72 cubic meter of soils contaminated with cesium, but really it was contaminated not only cesium, but cesium 137 was like marker for the contamination. So you see a good enough volume reduction, and the decontamination factor was practically also around the 5, was enough for economical reasons. And next step in the development of contamination techniques is development of laboratory installation. Why we repeat again to laboratory installations? Because you understand that the contamination factors very depends on the type of soil, type of contaminations. So really for normal operation of this mobile installation for different facilities, we need to modify our technology, because different kinds of soil needs maybe special dispersing of special method of segregation of sediments, and so for more flexibility of this technology, it was developed again laboratory installation. The first laboratory installation was developed, of course, before when we developed the old design. And so the main idea of this installation is modification of technology for real conditions of contaminated area, for different, for example, for different chemical combines. Like here we tested this facility and this installation for modification of this technology for Angarsk electrochemical combine. If you know, that was biggest Russian combine for uranium treatment. It was a lot of centrifuges for enrichment of uranium. So, because the problem of soil contamination of the Angarsk electrochemical combine also is very actual, and this soil washing techniques were modified for this purposes, for this combine. So, real result of this decontamination. So the first decontamination was not successful. It was very low, approximately 2 decontamination factors. So it means that just only 50% of soil was possible to remove from transported for free release. But after third generation of tests was reached more applicable the contamination factor, so it was techniques were good. The main advantage of this method.
So, sir, what are the factors in generations? Which factors are more developed or became more efficient as a result our DF factor increases? Which parameters were developed?
Sorry.
In generation 1, 2, 3.
Yes.
Which factor or parameter were efficiently developed as a result?
It will be. It should be equal. It depends. Just different decontamination factors was reached for different sites with different kinds of soils. So different type of soils. For Kurchatov it was good because it was really sandy soils. For application of laboratory test for Angarsk, it was more clay content soil, so the contamination factor was less.
So generation has nothing to do with.
It is no difference in the generation. It was difference in soil.
Soil.
So
in connection to that soil, we have on slide 3. Here slide 3 there is soil and clay.
Yes.
In two sides of the things, and we found that cation exchange capacity in sand is nearly 0, but in clay is 100%.
Yeah.
So we discussed to be in the whole school. Other lessons also we listen about porosity.
Yes.
But where is the factor of permeability? Because all cation migrations and transportation that directly depend on the permeability. How porous, for example, clay is porous, but it doesn't allow to transmit from A to B.
I think I understand.
But sand is porous as well as permeable. So
but here, the first step of treatment of soil is dispersion of soil. So we have not porosity. The soil after this treatment and in the process of treatment of soil washing process, the first step is disaggregation of soil. So we have no more porosity when we will treat this process. Yes, it's just only small particles.
Yes, yeah.
So, and but again, if for last results, for this, if you will apply here for this soil, for this final product of this facility, if you will apply ultrasound, we can increase. We will have increased the contamination factor because the particles will be disaggregated much more under the ultrasonic application.
So in ultrasonic, for example, the same way in ultrasonic, sand will be much better transmission of, because there is
not transmission
space, but soil is not permeable.
It's not permeability. It is just only disaggregation of soil.
Is the space between two interstitial spaces between particles?
You see, for example, when we will have just only simple disaggregation into the screw in our technology, we can remove, for example, just only maybe this particle, bigger one. But if we will apply the ultrasound, we will remove also the small particles, because ultrasound is more aggressive method for disaggregation of small particles. So we will treat these particles more efficiently.
Thank you.
So, but and for final, for advantage of this method, if you remember in the beginning of this presentation, I talked about chemical dissolution of contaminations. And for chemical decontamination methods, we will have no more soil. It will be just only chemical materials, maybe industrial waste, not contaminated waste. But it will be exactly not soil suitable for vegetation of grasses or plants. But after the soil washing, because all treatment are in water media, only water media, and because and even when we added our polymers, it is also very environmentally friendly polymers. So the soil are also all soil, not chemical materials. We can apply it directly for environment, and it's ready for vegetation of new types of soils.
You also have to treat the drainage water.
Yes, it's possible. Yes. So it was practically the same water soil, but without the the finest particles. But really, the structure it was practically the same soil, which are ready for revegetation. So we don't need to prepare the special area for storages like industrial waste or for construction works. We can apply it for agriculture applications. So it was very important for even for Fukushima accident. We explained for locals. So it is methods of decontamination, soil decontamination. So more questions, no?
Thank you. No more questions. Then we will proceed to the final test. Okay, this test is for us. So half of these questions are the same as Yes, in some questions, there can be, yes. Maybe one or two questions. After testing, we will deliver the certificates also, so but we have to wait 100 for this.
Я просто не уверена,
So in 15 minutes, we'll start the delivery of certificates, so we can just set a break. So in 15 minutes.
Просто хотелось бы, чтобы, не знаю, хотя бы просто переживаю, потому что в прошлый раз было.
Are you want to use this for
Вот что еще. Тема уже конкретное название есть какое-то.
Да.
Еще с английского.